The Pratt & Whitney JT8D-200 series engines are new versions of a well-established and reliable turbofan engine. This presentation will describe the engine's oil system. This system provides cooling and lubrication for the engine main bearings by means of 4 distinct, yet interrelated subsystems. The pressure system. This system supplies oil to the main engine bearings and the accessory drives. The scavenge system. This system withdraws the oil from the bearing compartments and accessories and then returns it to the oil tank. The breather system. It controls the air pressure in the bearing compartments to ensure proper oil flow and to maintain scavenge pump performance during engine operation. And the seal drain system. This system collects any oil that may seep past the numbers 1, 2, 3, and 4 bearing carbon seals and allows it to drain overboard. The pressure system utilizes an oil tank that, fully serviced, holds 5 gallons. However, the usable capacity is only 4 gallons. To determine servicing requirements accurately, the oil level should be checked within 2 hours after engine shutdown. Located in the tank is a screen. Oil is gravity-fed through this screen, then through a transfer tube, out of the tank to the main oil pump, which is located in the gearbox. The main oil pump is a positive displacement gear type. It has a maximum pumping capacity of 35 gallons per minute at takeoff. Pressurized oil flows from the main oil pump to the main oil filter. The -200 series engines use either a disposable 15-micron filter or a reusable 40-micron filter. Should the main filter become clogged and the differential pressure drop across the filter exceed 70 psi, this bypass valve will open to ensure continued oil flow. On the 40-micron filter, the bypass valve is internal. However, on a 15-micron filter, the bypass valve is attached to the cover. The pressure regulating valve is located in the gearbox. This valve is designed to maintain a controlled oil pressure that will provide the required flow through the oil nozzles in each bearing compartment and the accessory drive's gearbox. The regulator is set to obtain pressure readings of 42 to 45 psi at idle. From the oil pressure regulating valve, the oil flows through the fuel oil cooler, which uses fuel to cool the oil. Should the fuel oil cooler become clogged, this bypass valve, which opens at 55 pounds of differential pressure, will let the oil flow bypass the cooler. If an oil pressure change occurs within the oil system, this oil pressure sense line transmits that change back to the pressure regulating valve. The valve would then open or close slightly to compensate for the pressure change, and thereby assure continued proper oil flow. The oil then flows through last chance screens to each of the 7 bearings, providing lubrication and cooling. These screens, shown here in the cover of the number 1 bearing compartment, help to protect the oil nozzles from contamination. The scavenge system utilizes 4 gear-type pumps to return scavenge oil to the oil tank. From the number 1 bearing, scavenge oil is pumped to the gearbox. From the numbers 2 and 3 bearings, oil flows by gravity through the tower shaft to the same place. From there, another scavenge pump sends the oil back to the oil tank. Scavenge oil from the number 6 bearing is pumped through the oil transfer tube to the numbers 4, 4.5, and 5 bearing sump. From here, this dual-element scavenge pump, which is located in the diffuser case, returns the oil directly to the oil tank. In the tank, the oil passes through a de-aerator, which removes most of the entrapped air. The breather system interconnects all the bearing compartments, the oil tank and the gearbox. This is accomplished by either external tubing such as this, or internal passages. This system allows vapor-laden breather air to flow to the gearbox. Here, it passes through a rotating de-oiler that separates the oil from the air. It then vents the relatively oil-free air overboard through this overboard breather port. The last of the 4 subsystems is the seal drain system. If any oil should happen to seep by the carbon seals, it would be routed to an adapter on the gearbox overboard breather port. Oil seepage from the number 1 bearing compartment would be routed through a tube located inside this inlet guide vane, and then through an external tube to the adapter. If any oil from the numbers 2 or 3 bearing compartments should happen to seep by their respective carbon seals, it would be routed through 2 internal tubes, which are located in the struts of the intermediate case. From here, it would pass through external tubes to the adapter. The number 4 bearing compartment drains through a tube in the diffuser case, across the fan duct to a ball check valve. The check valve is located inside this line. From this line, which is mounted on the bottom of the engine, the oil seepage drains overboard. In summary, the -200 series oil system is comprised of 4 subsystems: pressure, scavenge, breather, and seal drain. Oil is pumped through the filter to the oil cooler. Then to each of the bearing compartments to provide lubrication and cooling. The scavenge pumps then return the oil back to the oil tank. The breather system controls the air pressure in the oil tank and the bearing compartments. The seal drain system provides for drainage of any oil seepage past the carbon seals. The great reliability demonstrated by the Pratt & Whitney JT8D engines depends in large measure on the proper functioning of the oil system.